let's see our 8th question under differentiation of natural logarithm. Alright? So now looking at this question. So let's see, please, I am going to advise you, okay? If you want to go by the other idea that I take 1 over the whole of this, imagine how the thing will be. 1 over the whole of the inside. And the derivative of the inside, that will give you quotient rule, no problem. But 1 over the whole of this, you see the work is going to be something basa. Alright, so now, in any time you are having such a question like this, I will advise you that you go by what? Expanding and what? Simplifying what? It. Okay? Alright. Don't forget it. It will help you. Okay. So you having a question like this, you can say that y is equal to ln x minus 1 to the power 4. And since it's divided, minus ln 2x minus 1. How you can see that? Alright, then from here you can take your what? Your differentiation. You see that when you apply your small algebra, the work becomes too simple for you because you're taking the derivative of this. So you are left to take, so the y ds is going to be you taking the derivative of x minus 1 to the power 4 minus the derivative of 2x minus 1 to the power 1 over 3. This thing is something that, oh, don't forget. Okay. So this is something that you know already, alright? So now, when you differentiate this one, it's going to be 1 over, so the y dx is equal to 1 over the inside, and the inside is x minus 1 to the power 4 times the derivative of the what? The inside, and the inside is x minus 1 to the power 4. Alright. Minus 1 over the whole that. So 1 over 2x minus 1 to the power 1 over 3. And the derivative of the inside. And that inside is 2x minus 1 to the power 1 over 3. You will have it. Just simple. You see that? Okay, so here you can get 1 over x minus 1 to the power 4 times chain or general power rule. So 4 multiplying x minus 1. Subtract 1 from the power, you get 3. Differentiate the inside, you get 1. How you can see that? Alright. Minus, repeat this. Okay. General power rule. 1 over 3 multiplying 2x minus 1. If you don't have a problem, take your calculator. 1 over 3. In order to be sure, and subtract 1 from it, you get negative 2 over 3. Alright, so let's continue with it. So here you can just simplify it, and then you see this will cancel this, right? So it will be left with 1 here. So we have 4 over x minus 1. Since the inside is the same thing. Minus this side 2. Don't worry yourself. Okay, so you can see it will be like only 1 in the numerator, right? Repeat 2x minus 1 to the power 3 times this one will come down because of the negative here. So you get 2x minus 1 to the power 2 over 3. So the inside they are the same. So it's something like 2 having a raised to the power 1 over 3 times a raised to the power 2 over what? 3. What will you do? You add, right? So you add. So let's add 1 over 3 plus 2 over 3. And that's going to give us 1. Therefore, dy dx is going to be 4 over x minus 1 minus 1 over 2x minus 1. And that becomes the end of your result. See, looking at your final answer, you can see that anytime you apply your properties of the natural logarithm, your final answer becomes something simple for you. But imagine you taking 1 over the whole of this, go and differentiate the inside that is pushing through on its own. It will be something like complex for you, okay? So always apply this simple thing. Take the derivative of each of it and you go your way. Alright, let's try the last question. That is question 9. Yes. Question 9. Let's assume that you have ln 2x over y minus sin y plus x squared is equal to 0. And you are to find the y dx. Be careful. We are taking it as respect to what? X. That's why we write the y dx. But remember that there are some of the functions in the question which is not in terms of what? Y. Sorry, which is not in terms of what? X. So it will become what? An implicit what? Function. So let's see. So let's rewrite this one, okay? We can write y is equal to, sorry. We have it equal to 0. So let's take the derivative of what? Each term. So, but we can rewrite this as ln 2x minus ln y sin y plus x squared is equal to 0. So you take the derivative of each. Ln 2x minus the derivative of each sin y plus the derivative of this x squared is equal to the derivative of this. Wow! So that's the derivative of each what? 10. Alright, so let's see what you're going to have. If you take the derivative of this, you are going to get what? Don't bring any equal to it. You are going to get 1 over 2x. In fact, the question is an implicit question. Okay, so 1 over what? 2x. Okay? Times the derivative of the inside, you get 2. Minus this one. Don't forget, 1 over what? Y. Wow. So the derivative of the inside will be, the inside is y. So when you differentiate y, you get what? Dy dx. Good. Dy dx. Minus, here, differentiate the whole thing. If you differentiate sine, you get what? Cos. So this will be cos y. But since we are taking the derivative in terms of what? As respect to x, and here is y, it becomes an implicit. So here will be dy dx. That's the differential of the inside. Plus this will give you what? 2x. Alright. Is equal to 0. So now, we just group like terms, right? The term containing dy dx. Let us come one side so that we can factor it out and conclude on our results. Alright. can see that, let's send, since the one in terms of the dual dx is being negative, let's send it to this side, okay? So we are left with, oh wow, this will cancel this. So we are left with 1 over x here, okay, plus 2x is equal to, send this one here, you get cos y dy dx. Then send this one to this side, you get plus 1 over y dy dx. Alright, so 1 over x plus 2x is equal to, you can factor dy dx out here. So dy dx come out, cos y plus 1 over y. Alright, so now dy dx is going to be equal to 1 over x plus 2x. All this over cos y plus y, 1 over what? Y. And then, that becomes the final results for such question. You don't understand anything? Go back the video, play it again. See you.